Tonight's homework is on circumference. We've been working to calculate the circumference of different circles in class. Problem number 5 is a little bit different. It says the ends of the track shown are semicircles, half a circle. So you look at where this runner is. He's running around the semicircular portion of this track, and this runner's doing the same over here. Exactly how much farther would you run by running one lap in the center of lane B, that's this outside lane, than if you ran one lap in the center of lane A? I think you can see that the runner that runs in lane A doesn't need to run as far because the circular portion of the track is a smaller circle than the circle that's out here in lane B. And this actually happens in running events. You'll see that they'll stagger the runners so that it's fair, so that to make up for this difference in length that the people on the outside lanes need to run, this extra length around the curve. In order to solve this problem, there's something you can do with your paper. If you fold your paper along this circular portion and along this circular portion, you can actually put the paper together and see that the two semicircular portions make a full circle. I hope you can see that on the camera. So that the distance run in this straight section of the track is the same for both runners. So if you want to know how much farther the person running in lane B runs, you really just need to consider the difference in the length of the circles, or the difference in the circumference of these two circles. So keeping in mind that these two semicircular regions or portions create one full circle, really all you're trying to do in this problem is find the difference between the circumference of circle B and circumference of circle A. And I'll highlight them here to show you what I mean. This runner that's running this semicircle, he's in lane B, he or she will also need to run this other half of that same semicircle. And the person in lane A has to run these two semicircles to run one lap, but they're much smaller circles. And so we're really finding the difference between circle A, the circumference of circle A, and the circumference of circle B. It's really hard for me to draw a circle on this writing tablet. Okay, so to do that, we just need to find, first we need to find the circumference of A, circle A, the smaller circle, and that's equal to pi multiplied by the diameter of circle A. And then we need to find the circumference of circle B, and that's equal to pi multiplied by that diameter of circle B. And then the difference will be, the difference between those two circumferences will be the difference in the amount that they run in one lap, because they run the same exact amount when they're running on the straight sections. The problem doesn't ask you to estimate, and it doesn't indicate that you should use 3.14 for pi. Some of the other problems, like if you look right below on problem number 6, it says find a rough estimate. For a rough estimate, we'll use 3. That's also suggested for problems 1 through 3. For problem 4 on your homework, in parentheses, it asks you to estimate using pi as approximately 3.14, but there's no mention of estimating or approximating on this problem, so we're just going to leave pi as pi. So why don't you try to substitute these values during the pause and come back and see if you can find the difference between the distances run on those two tracks.
Paused.
So the circumference of circle A is going to be equal to pi multiplied by the diameter of A. A is this inside track. They show us this 19 meters, but that 19 meters, remember if we put this whole circle together, that 19 meters is going from the center to the edge of that circle. So that's not the diameter, that's the radius. So one thing you need to realize here is that you have to double this 19, which is 38. That diameter, the distance all the way across and through the center of the circle, would be 38. The circumference of circle B is equal to pi multiplied by the diameter of circle B, which would be taking this radius of 20 and doubling it for 40. Whenever you're expressing circumference in this way, pi multiplied by 38, it's better to write 38 pi. We have 38 pi, and circumference of circle B is equal to 40 pi. But it asks how much farther you would run in lane B, the outside lane. So we want to take circumference of B and subtract circumference of A, which would be 40 pi minus 38 pi. In both terms, we're counting pi, so it's okay to subtract. It's like if I said $40 minus $38, that would be $2. 40 pi minus 38 pi is 2 pi. And the units would be meters, because these the radii are given to us in meters. So 2 pi meters would be the difference in the distance run by the runner in the outside lane compared to the inside lane. Okay, I hope that helped with the homework. I'll see you tomorrow.